What's up, scholars? Today you are in for a treat because we are talking about trigonometry. Trigono comes from the word that means triangle, and metry means measure. So we're talking about triangle measure stuff. Measuring some triangles. What can we measure in triangles? Obviously, their sides and their angles. But more interestingly, we can measure the ratios of those sides compared to the angles. Let me draw some triangles so we can talk about them. Okay, so here we have three triangles. And we see they are all right triangles. And then we see they're all similar, because this triangle is just twice as big as this one. And this triangle is 3 times as big as that one. So they're all similar triangles, which means whatever this angle is down here will be the same as that angle here, will be the same as that angle here. And whatever this angle is up here will be the same as this one, will be the same as this one. So when you have right triangles, if you know two sides of that triangle, you can actually figure out one of its angles. That's just based off of, if you have a side that is 4 units long and 5 units long, the third side will have to be 3 for the Pythagorean theorem to uphold. So you know information about this third side, and you know information about this angle. You also know information about this angle, just based off of the relationship of the ratios of sides here. Okay, what am I talking about? What I'm talking about are our trig ratios, sine, cosine, and tangent, abbreviated SIN, COS, and TAN. Sine, cosine, and tangent. Sine is the relationship of when you take an angle as a frame of reference. The symbol is theta, which means the angle measure, theta, aka angle. When we look at some angle as a frame of reference, the sine of that angle is the ratio of the opposite side to that angle to the hypotenuse. So, for example, let's say we're looking at angle C. That'll be our theta. That'll be the angle that we're thinking about. So, the sine of angle C would be the opposite side to C over the hypotenuse of that triangle. The opposite side to C would be 4 units long, and the hypotenuse is the 5. So it's 4 over 5. The sine of this angle is 4 over 5. And once we know that, I'll show you in a little bit, but we can go backwards and figure out what the measure of this angle is, just based off of the ratio of those sides. Because it'll be the same every single time, even if it's a bigger triangle. This angle is going to be the same thing because of the relationship of these two sides. So again, I'll show you in a minute how we can convert from this information to, hey, what is the measure of angle C? Right now we're just talking about the relationship of the sides, the trig ratios. Sine, cosine, and tangent. The sine of angle C is the opposite side over the hypotenuse, 4 over 5. How about the cosine of angle C? What would that be? Well, this says adjacent over hypotenuse. That's what the ADJ is, not adjective, but adjacent. So the cosine of some angle is the relationship of its adjacent side over the hypotenuse. So the cosine of C is its adjacent side, meaning the side right next to it, which is 3, over the hypotenuse, which is 5. So the sine of angle C is 3 over 5. And you might say, hey, the side that's 5 units long is also right next to angle C. So why is this the adjacent side? Well, this guy's always and forever the hypotenuse. Always and forever the hypotenuse. It will never be the opposite side. It'll never be the adjacent side. It will always be used as the hypotenuse. Which means the only option for the adjacent side to angle C, the side right next to it, is this guy right here, which is 3 units long. Okay, and finally tangent, which is really the most useful of these three trig ratios. Again, I'll show you in a minute why. The tangent of angle C is the opposite side to C over the adjacent side. So the tangent of angle C here is the opposite side, 4 over the adjacent side, so 4/3. Cool. We could find the sine, cosine, and tangent of angle B as well. They won't be the same. We can do that for all these guys. Let's do it for one more, actually. But we would never find the sine, cosine, or tangent in this case of the 90-degree angle. We're not going to use that. So let's just focus on the two acute angles in a right triangle. Let's pick some other angle to be the theta, to be our point of reference. How about H? So let's say we'll find the sine of angle H. Sine is opposite over hypotenuse. So the opposite side to angle H is 9 over the hypotenuse, which is 15. 9 over 15, which reduces to, if we divide both by 3, to 3 over 5. The cosine of H is the adjacent side over the hypotenuse. The adjacent side to H is 12 over the hypotenuse is 15. So 12 over 15, which reduces to, if we divide by 3, to 4/3. And then finally, the tangent of angle H is the opposite over the adjacent side. 9 over 12, which reduces, of course, to 3/4. Cool. All right. So these, again, are called our trig ratios. Trig ratios. And there is a mnemonic device to help you remember this. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent, which is SOHCAHTOA. Now this only works if you say it correctly. It's SOHCAHTOA, not SOHCAHTOA, is what I hear a lot of times. But this is SOHCAHTOA. Why is that helpful? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Alright, so I said the cool thing really here is that we can go from these relationships of side lengths to what in the dickens is that angle. Let's get on to that movie magic. Let's say, for example, we want to know, again, what angle C is. We know all these things about angle C. The sine of angle C is 4 over 5. So the sine of C, I'm just going to write this down over here, is 4 over 5, which is the same thing as 0.8. Sine of C is 0.8. Now, back in the Dark Ages, there used to be a table of values that you could go find 0.8, and that would correspond to some angle C. But we are not in the Dark Ages. We're not going to use trig tables. What we are going to use is the inverse sine of C. So bear with me here for a second. Let me explain why this step is true. Let's say, for example, totally different example, totally not related to what we're just talking about. I'm just using this to make a point. So we got 2x equals 10. This says 2 times x equals 10. To get x by itself, we would do the inverse operation of multiply, which is division. Right? Now we get x equals 5. Cool. So here, if we want to get C by itself, we need to get rid of the sign here in front of it. So we are going to do the inverse operation, which is called sine inverse. Sine inverse. We're going to do that to both sides, just like here we divided by 2 on both sides. So we'll have the sine inverse of sine of C will equal the sine inverse of 0.8. When we do that, just like here, the 2's canceled out. This sine inverse of sine cancels that out. So we have C equals, I'm running out, there we go. C equals the inverse sine of 0.8. The inverse sine of 0.8. Some of you will have calculators that could do that. It'll be, if you have sine, cosine, and tangent, on your calculator you have sine inverse and cosine inverse and tangent inverse. It'll be right above those buttons, so you have to use your second button to get there. Or we're going to go check out the internet. We go over to Google and we say, Google, I need a trig calculator. Someone else has searched for that already. Cool. Symbolab has all kinds of awesome math tools. I used Symbolab like in college. All kinds of good stuff here. So we looked up trig calculator, and we want the inverse sine, so sine to the -1 of, it was 0.8, and I press go, and it loads for me. Arcsine is another name for sine inverse, and that tells us that C is 53.13 degrees. C is 53.13 degrees. C is 53.13 degrees. Now, actually, we could have gotten this information if we used the cosine or the tangent. And just to prove a point, I'm going to do that real quick. Okay. So, we had the cosine of C equaled 3/5, so we want the cosine inverse of 3/5, which is 0.6. Plug that in. And drum roll, please. We get 53.13 degrees. Excellent. So the cosine would give us that same information. And the tangent of C was 4/3. I'm not going to try for that as decimal, so I'll just do division 4/3. Plug that sucker in. Is it going to give us that 53.13 degrees? Pretty sure it's going to, because I know how this works. Yes, 53.13 degrees. Again, we plugged in the inverse cosine of 3/5 from that guy and the inverse tangent of 4/3 from that guy. We got that C was the same answer every single time. So, what this means is, if you know an angle, or you know some side lengths, you can solve for the thing that you don't know. Well, how do we use this? Alright, say one day you're walking, and you see this really giant tree, and you're like, oh my gosh, how tall is this super giant tree? All I have with me is my phone. How could I figure out how tall this is? So if you walk 20 feet away from that tree, and then you use your phone to sight the top of the tree, like you're going to look up at the top of the tree, like with your phone next to you, and there's an app on there that will tell you the angle of elevation, or how high you're looking up. So you'll look up at the top of the tree, you have your phone there measuring this angle, theta. It's going to go all the way to the top of the tree. And we've now made a, well, it really should be putting the side of the tree, shouldn't it there? Yeah, cool. We've made a right triangle where we know that we walked 20 feet away. We know this angle measure. Let's say we measure it to be 70 degrees using that clinometer phone app. Clinometer. I actually used to use the low-tech version of this to measure this angle of inclination. So if we know that we walked 20 feet away, that's a 20 feet. 20 feet, this is 70 degrees, we can find the height of this little chunk here, right? We could find the height of that Let me redraw the triangle we're working with. Clearly not to scale. This is 20 feet, this is 70 degrees, and this is the height that we're looking for. So we know this 70-degree angle. We know the side opposite the 70-degree angle is the side we're looking for. And we know the side adjacent to that 70-degree angle is 20 feet. What relationship used opposite and adjacent? Ah, it was tangent. Tangent of some angle is the opposite side over the adjacent side. So the tangent of 70 degrees is our opposite side, h, over our adjacent side, 20. We want to find h. We want to find that opposite side, so we multiply by 20 on both sides. That cancels out. We have our height is 20 times the tangent of 70 degrees. So we go to our handy-dandy calculator. Again, we're still over here in Symbol Lab. I typed in 20 tan 70, plugged it in, and got 54.9. Let's round it to the nearest. Oh, let's round to the nearest tenth, shall we? So we'll say 54.9 feet is how tall our tree was. Actually, pretty close. So this H, from the top of the tree to where we looked at it, that is 54.9 feet. But we really want the whole height of the tree. We got to think about this part. How tall are we? Let's say, for simplicity, we are 6 feet tall. So the whole thing, from the top of the tree down to the floor, is 54.9 plus 6. So the tree is 54.9 plus 6 is going to be 60.9 feet. That is a tall tree! Alright, now let's check out an Alex question. It says, using trigonometry to find angles of elevation or depression in a word problem. Kind of like the tree thing we just talked about. In this one, a plane is 136 miles north and 184 miles east of an airport. Okay, cool. We're going to find x, the angle that the pilot should turn in order to fly directly to the airport. Now, obviously, they wouldn't fly directly to the airport because they'd be, like, crashing into the ground. But that would be the fastest way to get to the airport. So it's probably somewhere in the middle. Maybe they use this for estimating how long it's going to take to get there. Good information to have. Anyway, find x, the angle that the pilot should turn in order to fly directly to the airport. So I'm going to recopy this triangle onto a piece of paper so we can talk about it. It's got 136 right there, 184. We're looking for x. And of course, it's a right triangle because all the stuff that we do with this trig has to have right triangles for this to work. Okay, so we are looking for x. We know the side opposite x is 136. We know the side adjacent to x is 184. So again, what relationship are we going to use that has the opposite side and the adjacent side? It's our good friend tangent. Tangent of some angle is the opposite over adjacent. Cool. So we are looking for tangent of x. That's the angle that we have. The opposite side is 136. The adjacent side is 184. We want x. So what are we going to do? The inverse tangent, or arctan. Same thing. I like to call it inverse tangent. I don't know why. I just prefer that. So that's what I'm going to write. 136 over 184. Those will cancel. X will be the inverse tangent of 136 over 184 to the internet calculator. Alright, we wanted the inverse tangent. Inverse tangent. Tan to the negative 1 of 136 divided by 184. 84. Too many parentheses. That looks better. Loading, 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 loading. Ah, excellent. 36.47 degrees. 36.47 degrees. 0.47 degrees, which means the pilot should turn the airplane 36.47 degrees downward in order to go directly to the airport. So, quick little recap. We talked about trigonometry, which is triangle measures, specifically relationships of sides compared to angles. Those relationships are sine, cosine, and tangent. Sine of some angle is the ratio of the side opposite that angle to the hypotenuse. Cosine is the side adjacent to that angle over the hypotenuse, and tangent is the opposite over adjacent. You can use this little mnemonic to help you remember that sine is opposite over adjacent, cosine adjacent over hypotenuse, and tangent opposite over adjacent. SOHCAHTOA is what that is, but you'll have your notes, you'll have the internet, so you don't have to memorize it, but if you want to, because it's speedier, go for it. We talked about using the inverse functions, inverse trig functions, to go from the ratio of those sides to what that actual angle is. We talked about how you could find the same answer for the angle measure using the sine or the cosine or the tangent if you know all three sides, sine or cosine or tangent, of the various side ratios. And we talked about using the angle of elevation to figure out a height or the side lengths to find the angle of depression. Cool. All right, scholars, that's it for our trig lesson. Love you so much. Keep on that hustle, and I'll see you next time.